Hey everyone, welcome back to Syntax Grid. If you're new here, make sure to check out our previous videos and playlists where we've covered essential ML concepts and statistics. In today's video, we're diving into conceptual questions on statistics. Question 1. What is the purpose of a statistical test? A statistical test helps you decide whether the results from sample data are strong enough to support or reject a hypothesis about a population. Test hypotheses used to validate assumptions about population parameters. Analyze sample data evaluates evidence from a subset of the population. Reject or accept H helps you decide whether to keep or discard the null hypothesis. Find significance determines if an effect or difference is statistically meaningful. Drive decisions supports making informed business or research decisions. Question 2. What is a p-value? The p-value tells you how likely it is to get your sample results if the null hypothesis is actually true. A smaller p-value means stronger evidence against HO. Probability under HO shows chance of getting observed result if HO is true. Low p-value reject HO, a value below 0.05 typically leads to rejecting HO. High p-value keep HO suggests the observed result could be due to chance. Note effect size doesn't measure how large or important the effect is. Statistical evidence acts as the main metric in hypothesis testing. Question 3. What's the difference? Test versus z-test? Both are used to compare means, but tests are for small samples with unknown variance, while z-tests are for large samples with known variance. T-test small, unknown variance ideal when population standard deviation is unknown. Z-test large, known variance used when variance is known and sample size greater than 30. Compare means both test if group means are significantly different. T-distribution used T-test relies on students' distribution. Z-distribution used Z-test assumes a normal distribution. Question 4. What are parametric versus non-parametric tests? Parametric tests assume a specific distribution like normality. Non-parametric tests don't rely on such assumptions and are more flexible. Parametric normal data requires data to follow a known distribution. Non-parametric flexible works on data without strict distribution rules. Parametric mean-based analyzes means and uses variance. Non-parametric rank-based uses medians or data ranks for testing. Choose based on data selection depends on data type and assumptions met. Question 5. When do you use a chi-square test? A chi-square test checks relationships between categorical variables using observed and expected frequencies in a contingency table. Categorical data used when variables are in categories colors, types. Test independence checks if two variables are related or independent. Observed versus expected compares actual counts with expected frequencies. Contingency tables often apply to tables with rows/columns of categories. Large sample needed requires a sufficiently large dataset to be valid. Question 6. Explain ANOVA briefly. ANOVA analysis of variance tests whether there are any statistically significant differences between the means of 3 or more independent groups. Compares 3+ groups designed for more than 2 groups. Tests group differences determines if any group mean is significantly different. Uses F-statistic calculates the ratio of variances to find differences. Assumes normality and homogeneity, requires normal distribution and equal variances. Extension of test generalizes test to multiple groups. Question 7. What are type I and 2 errors? Type I error occurs when you wrongly reject a true null hypothesis, and type 2 error occurs when you fail to reject a false one. Type I equal false positive, you wrongly reject a true null hypothesis. Type 2 equal false negative, you fail to reject a false null hypothesis. Balance needed reducing one increases the chance of the other. Affected by sample size and test power influence error rates. Minimize with good design, use proper sampling and test choice to reduce errors. Question 8. What is a paired test used for? A paired test compares two related groups like before and after measurements to see if there's a significant difference in means. Same group compare twice measures before/after effects within the same sample. Test mean difference evaluates if there's a significant change. Dependent data, both values must come from the same subjects. Assumes normal differences should be normally distributed. Used in a/B testing, ideal for testing product changes, treatments, etc. Question 9. When should you use a Mann-Whitney U test? The Mann-Whitney U test is a non-parametric test used to compare two independent groups when the data isn't normally distributed. For non-normal data, best when normality assumption fails. Compares medians tests for central tendency differences using ranks. Two independent groups must be unrelated. No normality needed, makes no assumptions about distribution. T-test alternative useful when data is skewed or ordinal. Question 10. How do you check assumptions before tests? Statistical tests often require assumptions like normality or equal variances. You should check these before choosing and applying the right test. Normality Shapiro/QQ plot use tests or plots to check distribution. Equal variance Levine/Bartlett's tests whether group variances are similar. Independent study design ensure no relationship between sample observations. Visual tools help box plots. Histograms can show issues clearly. Assumptions guide test choice. Pick the test that fits your data best. Thanks for watching. If you found this helpful, make sure to check out our playlists on machine learning algorithms, statistics for data science. Don't forget to give it a thumbs up and subscribe to Syntax Grid for more data science and machine learning content.